In this video, I will go over the homework that follows the lecture 1.2 called Differentiating Exponential Functions. And as always, I hope you watch these lectures as I will be referencing the content and expecting you to know or be familiar with it somewhat. So let's get started with the homework 1.2. And the main concept that we are going to practice in this homework is the fact that derivative of an exponential function is, if it's a natural exponential function, it's the function itself. And if it's not an exponential function, or I'm sorry, if it's not a natural exponential function, but rather some other exponential function with base b, then the derivative of that function is b to the x times ln b. This is what we've learned, and of course, because of the chain rule, let's say if you start combining exponential function with something else, we know that, so let's say if we take e to the power g and try to take the derivative of that, we know this will be equal to e to the power g of x, because the derivative of e is the function itself, times g prime x. And vice versa, if we have e to the x as the input to some other function and we try to differentiate it, then it will be the derivative of g evaluated at e to the x times derivative of the inner function, which is e to the x. So these are the main ideas, and of course we should also be able to find the derivatives using the product and the quotient rules, and also the linearity of the differentiation. So let's get started. Here we have a function k of x, which is e raised to this. It's not a polynomial, but kind of like polynomial in terms of we're not going to have as much problems differentiating it just like polynomial. And to find the derivative of k, we're going again acknowledge that we have e to the power g of x. So the derivative of k will be the function itself, so it's going to be e to the power g of x. But we also have to multiply by the derivative of that g according to the chain rule. So we're going to multiply by, and here goes the differentiation of that exponent. And I'm not managing my space well over here. Forgive me for that, but let me just carry this over. So we have negative 1/2 x to the power negative 3/2. And I'm going to rewrite it once again. Hopefully this time I'll manage the space better. So remember, all of this is in the exponent. And the derivative of the function is at the same level as e. So we have here negative 1/2 x to the power negative 3/5 minus, so we have plus 5/2 x to the power negative 3/2. And that's the answer. I think the hardest part will be actually copying it over. And let's check. And one way to check your work without crossing the red line is to do something like this. So there's no harm in trying to graph this function. So I'm gonna type it again. Oops. So this is the function. This is what it looks like. Looks pretty flat, but we're just not zooming in far enough, and so this is what the graph looks like, right? So it's a pretty cool function. Now what we can do is we can type the answer, what we found to be the answer. So let's call it f of x, and I'm just going to use the power of copy and paste, and I'm going to type the rest here. So this is what we think the answer is. And the question is this the derivative of that? And we can check by simply typing the derivative of k function, and we see that according to Desmos, the green function is the derivative, but it perfectly overlaps the blue function, so that's how we know that we got the right answer. And I wouldn't consider this cheating, for example, because this was an intelligent way of just checking the answer. We didn't use Desmos to find the answer, we just used it to check if it's right or wrong. And our answer is right, so moving on. We have another k function. In this case, we want to recognize right away that we have a product, and we're going to treat this as a product of two functions. So our answer will be the u prime v plus u v prime. And u is negative 4x, v is e to the negative 3x to the power 4 minus 2x cubed. And we can easily find the derivative of u derivative of u is we have, it's going to be 4 over x squared. How do I know that? Because we can rewrite this function as exponential function and use the power rule. And derivative of v, to find the derivative of v, we're going to recognize this as e to the g. So derivative of v will be e to the g times g prime, where g is this right over here. So e to the g is, I'll bring it over here, it's the function itself. And g prime, here I'm going to use the power rule and the linearity, as the exponent is a simple polynomial. So we have negative 12x cubed minus 6x squared. So now we can find the derivative of k. It's going to be u prime times v plus u times v prime. And we can simplify this. I'm going to try to simplify it real quick. And if you follow, that's great. If not, then you can always enter the answer in not simplified form. But I'm going to factor what they have in common. And we're going to distribute this 4 over x over. So we have 48x squared plus 24x. And it looks a little weird. So let me just bring it down a bit. There you go. So this is my final answer. E to the power negative 3x to the power 4 minus 2x cubed. 4 divided by x squared plus 48x squared plus 24x. And Newton should recognize the implicit multiplication. That is when we don't put multiplication sign in front of the parentheses right over here. So this is called implicit multiplication. Now you may ask, why didn't we use the quotient rule? And the answer is we don't like using the quotient rule after we learn the chain rule. So quotient rule is our least favorite rule of all. All right, let's move on to the next question. We have h of x and here what we should recognize is that we have a function like this. So to find its derivative, we can use the linearity and take out the constant, and then to find the derivative of e to the g, we write e to the g times g prime. So that's the plan. And I'm just going to write out the answer. So we have negative 6 e to the power 6 sine 3x. And now to find the derivative of g, we pretty much have to differentiate this. So similarly, we have a constant, we have a sine function of, I'm not going to call it g, but let's call it f, since f is not used. And derivative of this, again, by linearity, we can take out the constant, and then by the chain rule, it's going to be the cosine of f of x times derivative of f of x. And that's the plan. So here we execute it. So it's going to be 6 cosine 3x times the derivative of 3x, which is 3. So we can collect all those coefficients together. So we have 6 times 6 times 3, which is 108. And I'll just write cosine of 3x in the front and e to the power 6 sine 3x in the back. This problem kind of wants us to use the quotient rule. Totally looks like it, but it really depends on you and how comfortable you are with the chain rule. But let's practice the quotient rule. So we're going to recognize this as the quotient, and to find the derivative of k, we're going to use the quotient rule. And u is equal to, and we have a negative here, so negative doesn't affect the differentiation, so I'm just going to keep it here in the front. And u here is e to the power negative 2x cubed, and v here is 4x to the 4, and derivative of u is, by the chain rule, is going to be e to the power negative 2x cubed times negative 6x, and derivative of v is simply 16x to the power 3. So derivative of k is going to be negative v squared in the denominator And in the numerator we have u prime times v minus u times v prime. And it looks like we can simplify this and reduce it by a lot. So let's take out the negative 8x cubed times e to the power negative 2x cubed. So we have left here 3x squared plus 2, and in the denominator we have 16x to the power 8, and this can be further reduced to negative, and we still have negative in the front. So negative and negative cancel each other, and this 8 reduces 16 by 2. This x cubed reduces x to the 8, makes it x to the 5. So the final answer is e to the power negative 2x cubed times 3x squared plus 2 divided by 2x to the power 5. And it may seem like I made a mistake, but it's just how I typed it. Or not. Something like this would happen once in a while, so we just want to make sure. It's just unfortunate that I made a typo and the wrong answer, so I don't have a second chance here. But let's find the mistake. Give me a second. So we have u prime. Oh boy. So derivative of 2x cubed is negative 6x squared. So we have negative 6x squared here. So we have, this is 3x cubed, so this is 3x cubed. So that was the mistake. So let's just check with the right answer. We also lost the negative along the way. What happened to the negative? Dun, dun, dun. Derivative of u, is there a negative? Yes, there's a negative. So in the correct answer here, you see how they have a negative and then this negative, so they should cancel. But in the final answer, they lost the negative on the outside. So, and I'm curious how they lost it. Oh no, they didn't. I'm just blind. There is a negative right over here, so this is the right answer. Even though we got marked wrong for it, we were able to get the right answer. It's going to take us back a few problems maybe, but it's just more practice, which is a good thing. Another function. So now we have an exponential function multiplied by, technically it's a radical function, but it's written as a polynomial, so it should be easy to differentiate it. We recognize this as a product, so we're going to find the derivative as using the product rule. I'm going to start skipping steps and try to be more efficient here. We're going to use the product rule, so it's u prime v times plus u v prime. U prime is e to the x, v is just me copying this, plus, now we had u prime v, now we're going to have u v prime. And derivative of this is going to be negative 2/3 x to the power negative 1/3. And derivative of this will be plus 2 x to the power negative 5/2. That's just me differentiating that function. We can, of course, factor out e to the x and simplify it, but and that's actually what I'm going to do when I'm writing the answer. So here we have negative x to the power 2/3 minus 4/3 x to the power negative 3/2 minus 2/3 x to the power negative 1/3 plus 2x to the power negative 5/2. All right. So it took us 5 problems to get through one objective, so probably another 5 to get through the remaining problems. We have a product. It looks like a product, but it's just a coefficient. So here we definitely need to recall the derivative of b to the power x as b to the power x times ln b. And we're also going to remind ourselves how to combine the chain rule and this rule. So derivative of this function will be derivative of the exponential, so it's going to be b to the power g times ln b. And then we're going to multiply by the derivative of g because of the chain rule. So in our case, g is negative 5 cosine 6x. So finding derivative of g may not be a trivial task, but by now we should be comfortable with it. So it's going to be negative 5 times negative sine of 6x times 6. And I can simplify it. So it's going to be 30 times sine of 6x. And now we're going to put it all together. So derivative of f is going to be b. So the constant doesn't affect differentiation, so I'm just going to write it out. Now it's going to be b, which is my 7, to the power whatever that function is, times ln of 7. And now I'm going to, by the chain rule, multiply by the derivative of g, which is 30 sine of 6x. That's the final answer. So to write it out, I'm going to collect all the coefficients in the front. So we have 150 ln 7 times 7 to the power negative 5 cosine 6x times sine of 6x. All right. Quotient rule. According to the quotient rule, derivative of f will be u prime v minus u v prime divided by v squared. So if my u is a to the x, then u prime is a to the x ln 8. And if my v is a to the x plus 9, then v prime is a to the x ln 8 plus derivative of 9, which is 0. So putting it all together gives us this. U prime is 8x ln 8 times v minus 8x times v prime all that divided by v squared. Looks like we can simplify it. 8x ln 8, 8x, and here we have 8x, 8x ln 8, so it cancels, so the only thing that's left in the denominator is 9 ln 8, 8 to the power x. That's the final answer. This parenthesis not necessary because there's no ambiguity there. So I'm just going to remove it. Here we have a product rule. And I'm not going to write it out because you've seen it before. I'm just going to apply the product rule. So derivative of u, which is negative 6x squared, times v plus u times derivative of v. And to find derivative of v, I'm going to do this work here. I'm going to recognize that here I have a to some power g of x. So derivative of v will be 8 to that power times ln 8 times g prime. And since g is 7 times x to the power negative 1, g prime will be negative 7 x to the negative 2. And so here goes my derivative of v. So right, I guess over here. Right over here. So v prime is 8 to the power 7x to the power minus 1 times ln 8 times negative 7 x to the power negative 2. So the final answer will be, and I should put derivative over here. So derivative of f is negative 6x squared 8 to the power 7x to the power negative 1 minus 2x cubed v prime is 8 to the power 7x minus 1 times ln 8 times negative 7 x to the power negative 2. And we can definitely simplify it, so we can take out 8 to the power 7x to the power minus 1. And here we have left negative 6x squared. And here we have plus 14 ln 8, and we have x. And we can take out probably 2x, but we don't have to. So let's see, 8 to the power 7 over x, and I'm going to take out, I'm not going to take anything out, minus 6x squared plus 14 ln 8 times x. That's the final answer. We have derivative of f of x will be the derivative of 7 to the power g. So by the chain rule, it's going to be 7 to the power g times ln 7 times the derivative of g. And since g is negative 4x plus 1 plus 2 over x, the g prime will be negative 4 minus 2 over x squared. So putting it all together gives us 7 to the power negative 4x plus 1 plus 2 over x times ln 7 and times negative 4 minus 2 over x squared. Hopefully this is the last one. Oh no, one more. Remember we said 5 more. Let's try this one. Product rule. Right away we can recognize that. So this is my u, this is my v. Derivative of u is 7 to the power x times ln 7. Derivative of v is just negative 6 minus 2 over x squared. So f prime is equal to u v prime plus, I changed the order, so I said u v prime, actually, plus, yeah, so here's what I did. I said u v prime, so next I'm going to write u prime v. Usually we write it u prime v plus u v prime, but it doesn't matter. And here it looks like we can factor out and simplify, but I don't think it's going to simplify anything. So I'll just take out 7 to the power x, but I'll keep the rest in parentheses. Negative 6 minus 2 over x squared plus ln 7 times negative 6x plus 2 over x. And we are done with this homework. If you have any questions, please reach out.